BOSH and GPU is a match made in heaven. A little about me, I'm a BOSH engineer. I've been using BOSH since 2013, back when it was trusty and we were using this terrible tool called Spiff. And I've been on the BOSH team since 2021, so about a few years. So this is kind of my journey of getting a GPU working on BOSH. Hopefully some of the lessons learned in the process that I've gone through to try to get to this point is helpful for anyone, and just the new future of using GPUs. So this all started kind of late 2022, early 2023 when ChatGPT came mainstream. Everyone's all excited about AI. AI's been around for a while, but now they're all excited about it. And then it's when I realized my brother-in-law, who's a teacher, was using ChatGPT to come up with lesson plans and do all these things. I was like, that's interesting that people are like using AI more than, that we are actually talking about. So I was like, how do we get GPUs working on BOSH, right? Like GPUs are such a main part of running a system like ChatGPT. So why do it at all? Curiosity, right? Trying to do something that hasn't been done was, always an interesting challenge. I love BOSH. I've been using it for so long. It's great at managing the lifecycle, such as scaling, updates, repaving, all the things you get with BOSH of adding disk, scaling disk. So it makes sense to have GPUs there, right? And combining the power of BOSH with GPUs can kind of help us develop different types of applications running on Cloud Foundry. We all love Cloud Foundry here. We like pushing apps, but what if we had AI and generative AI running as with Cloud Foundry? So where do you even start? I just started Googling, right? Like, how do you run a GPU on GCP? I came up with two conclusions. There was two ways to attach it. There's called an accelerator optimized machine type. So these are machine types on GCP that have GPUs attached to it. There's also a field called accelerators to the cloud properties. When I started digging in the code, it was already in there. It was just not advertised that the CPI could do that. Another note, you had to set on-host maintenance to terminate. The default value of that is migrate. So with VMs running on the cloud, the host might be terminated and they could just migrate your VM on GCP. But with GPUs, it's much harder to migrate a workload from machines. So what does this look like from a cloud config level? You can kind of see here we have an N1 standard 8. This is just a normal machine type. We set up the accelerator. We're putting a Tesla T4 on this. The count, you can have 1, 2, or 4. And then you set the root disk type, and then you set the local ephemeral disk to the SSD, and you can kind of see the on-host maintenance terminate. So AWS was pretty easy, actually. It's just an instance type. It's G4DN, which equates to a T4. I had to make some changes to the CPI to get this working. We didn't support this instance type. So as a V100, we support this now. vSphere, it's a little bit more complicated. There's two different ways to run a GPU. One is called pass-through. So what we do there is we take the GPU that's on the host and we pass it to the VM. With that, we have to specify the vendor ID and the device ID, which you can find in vCenter. And then NVIDIA has their own kind of way to like split up a GPU. GPUs, like especially the higher end ones, have a lot of memory, and you might not want to use all the memory for a certain VM. So it's called vGPU, so it allows you to like split up the memory of a GPU. It requires the NVIDIA license to use, and then this is how you define it here. This is all working as a V97. It kind of took a lot of work and a lot of like messing around with the code base to try to understand how do you pass a GPU to the vSphere CPI. Azure, personally, I haven't tested much of Azure at all, but it's just an instance type apparently, and somebody has ran this and it seems to work. So what's next, right? Getting the GPU drivers, there was a lot of challenges that came with this, right? Like we need to install the drivers for the machine, but our stem cells historically have a small root disk. So when you try to install any of the drivers, it takes too much space and you can't. So my first thought was like, what if I built a custom stem cell with the drivers installed? So I got that working on GCP, and then I moved to vSphere. Turns out it doesn't work for vGPUs. The same drivers don't work. So as I start pondering that problem, you think of there's more GPUs coming in the future. So like you don't want a custom stem cell for every single one. Because custom stem cells at the end of the day are kind of hard to maintain. You don't want to be the ones maintaining the CVE updates and all that. And so just overall, you don't want all the different combinations of CPUs. So as I kind of went through all these iterations, I thought about a better idea is to fix all the CPIs, kind of. And what I mean by that is allow the CPIs to expand the root disk. So AWS, turns out there was already support for that. vSphere, my coworker Brian Cunney, he saw this challenge I had with root disk and ended up helping me add this feature, and it's in 97.06. GCP is kind of like this weird little, it works, but it's the way the CPI is written, when you specify root disk, it uses anything over 5 gigs as the ephemeral disk, so that doesn't work. So if you attach a local disk, it uses the local disk for the ephemeral disk. Azure already supports it. OpenStack is unknown. I don't have an OpenStack cluster. Getting a GPU on an OpenStack cluster is probably even another story. So I just kind of skip that over. So how do we install the drivers? Turns out it's pretty easy. Just a simple pre-start scripts. I cut it out, but I have a sample repo at the end where you kind of install Debian package, and then you install the CUDA drivers, which installs all the NVIDIA drivers you need to run machine workloads. You also need to not remove the dev tools. So there's a BOSH environment variable that removes dev tools from the running machine. So we need that to recompile the kernel for the GPU. So kind of to recap the GPUs and drivers, it's just different VM types for the different IaaSes, but we can kind of have the similar experience between the things. At the end of the day, expanding the root disk to install the drivers was the best option, and just installing the drivers on the pre-start. Is this the best approach? I don't know for sure. I've been through many iterations of custom stem cells or stem cells with bigger root disk, but you don't want to have a bigger root disk if you're not going to use it for other things like Diego and stuff like that. So this is at least a solution where we can use the base stem cell that's being released and not have to rely on a custom stem cell maintenance and all that work around that. So what do you do with the GPU, right? Like you have a GPU, what do you do with it, right? So I had this great idea that I was going to run this in Diego containers. So I took up Cloud Foundry deployment and started hacking it through, trying to understand how the containers work on Diego and how do we pass through the libraries. These are kind of some of the conclusions. Python libraries with GPUs are very big. They're like 10 to 20 gigs. So when you're copying the droplet back and forth and trying to scale, it's not a great experience. And then in order to get the container drivers to work through the containers, I needed to run it as privilege. And I don't love running root containers on a production system. And then with GPUs, there's no multi-tenancy at all. So either you have a GPU or you don't. So kind of trying to understand the problem of like, okay, this works, but if we were trying to move this to the next level of trying to get this code into Cloud Foundry, would this even be viable? Is it helpful for other people to have GPUs? And like it wouldn't work well in production, I believe, just moving big droplets back and forth, not having a way to determine like who gets a GPU, right? Like you could use isolation segments to kind of put some GPUs there. But at the end of the day, I think if you want to do kind of ML ops and have access to GPUs, Kubernetes has a better story around all that. So kind of skip that on Cloud Foundry. So I just wanted to define a quick term before we move on to the next section. What is an LLM? It's a large language model. So ChatGPT itself is a large language model. Large language model at the end of the day is just a type of AI that can recognize and generate text. This is powerful because it kind of enables users of systems to like interact in a more natural language that they haven't been before. So somebody who's not a developer might be able to talk to a system to find out data around a system. So my next idea is Cloud Foundry has a great service broker system. What if we offer LLM as a service? What if we just did CF create service and now we have a LLM? So by offering ChatGPT as a service, we can use the OpenAI API to allow developers to use that. This service would be able to enable like developers to start adding these chatbots and all these with their own data within their own Cloud Foundry system. So there's a concept of RAG apps that I'm going to show in action in a second. So what is a RAG app? A A RAG app is a retrieval augmented generation app. This is kind of the new type of applications you might see when you talk about AI. And this is what a system that's running GPUs on BOSH might look like, right? We have on the left, we have Cloud Foundry running on a Diego app that might be connected to a database. So the database, they call them embeddings to store information about your own data. So each application will have its own unique Postgres database with its own data set, and then it would talk to my OpenAI compatible server that's running within BOSH, right? And this OpenAI server is actually proxying back to different LLM models out there attached to GPUs. So this will kind of allow us as operators to also scale the GPUs and run it in different ways. And with BOSH, we can kind of move different infrastructures without worrying about different things. Okay, quick demo time. Okay, I don't know if anyone can read this. So this is my deployment. So I'm going to SSH into my worker VM. Can people see this bigger? So we can kind of see, I just wanted to show you the GPU running on the BOSH VM, so we can kind of see my Python app. Since we're using it on vSphere, we don't get to see the fancy GPU like processing go up and down. It's using kind of the vGPU that I was talking about, but like this is kind of, hey, this is like started running on BOSH, so I can scale this out, run more different workers if I have GPUs available. And one of my coworkers saw that we were creating the GenAI tile, and he was like, sweet, can I write an app on it? Turns out he's a really smart guy, and he loves writing apps. So he wrote this great app that's actually trained on the Cloud Foundry open source documentation. So he scraped the documentation, created embeddings, stored it in the database, and then this is the app. So tell me about container metrics. So you can kind of start seeing that like the chatbot is now being like, hey, this is the components, collect different ones. Let me make this bigger so people can see. So this is kind of like an example of like, hey, this is pulling straight from the open source documentation. It's going to kind of give people information. So as like these things evolve, it's able to help people, get information quicker and not sift through lots of documentation and stuff. So I think there's going to be a lot of different applications that could be written for this. So yeah, that's a quick demo. So whoops, not showing. Switch displays. Okay, so what's next needed on this? EFI support. Turns out the stem cells have been booting in this way called BIOS. So we've always had BIOS boot on our stem cells, but as the new GPUs come out, so any GPUs that support over 16 gigs, it needs EFI support. So this is a huge work in progress that I've been trying to get working for Noble, because we're releasing Noble in probably the next 6 months for a stem cell release. So I'm trying to add support to AWS and GCP. I don't have any vSphere Azure like expertise, so I haven't spent any time on expertise, but my proof of concept at this point, the code works for AWS and GCP and vSphere. We just gotta fix up Noble to kind of work for everyone. So I have a sample BOSH release at my GitHub. If anyone wants the cloud configs, it has the pre-start scripts. It just kind of gets the GPU working for you. I think there's great power in trying to figure out what kind of workloads we might use GPUs for now if we have access to it on BOSH. There's just so many different things we could do. Image recognition, we can make different APIs. The service broker system is really great with Cloud Foundry, so if we can enable all these types of different applications, like developers can have access to that. And you can find me on GitHub or CF Slack as Nguyen. Thank you. Does anyone have questions?
We volunteered to do the OpenStack CPI one.
Okay.
That was not a question. Does anyone have any questions? Yes, Nick.
Hey, Long, I promise I'm not a plant, but what about if you don't have any GPUs?
Then you're gonna have to figure out how to get it working on CPUs.
Oh.
GenAI is such a different space, so we at VMware Tanzu is trying to also experiment with trying to get LLMs working on CPUs as well. So there's just like different ways to run it. So like CPUs are a lot slower, but I think there's a lot of work coming out of Intel right now that they are trying to make it at least fast enough. So, but CPUs are scalable, so we can kind of add more VMs. So the LLM as a service has kind of like evolved. It's like, hey, how do we like bring these type of services to Cloud Foundry? I think it's an exciting time, an exciting space, and I feel like BOSH can kind of keep up with the world if we're able to add GPUs and stuff.
All right, cool. Yeah, keep your eyes posted for what we're doing there.